Hello ladies and gentlemen, and what we're going to do now is we're going to take a look at an example of curve sketching in calculus. Remember, we had just gone over this in the video before, and all of this information is in a nice little format here that I will upload to the LMS, and it'll be there's an attachment for you, and it's going to give you a list of what we're going to go through. We're going to look at the domain, we're going to look at the intercepts, we're going to look at the symmetry, we're going to look at asymptotes, we're going to look at intervals of increase and decrease, we're going to look for any local maximums or minimums, and then we're going to take a look at any intervals of concavity, and that's through the second derivative test, and then we're going to sketch it all. So this is a sheet that's going to have all the procedures laid out on it. It basically has all of this information just on one typed sheet. So that's grade 11, we'll get rid of that. Okay, so the example I'd like to do with you now is sketch the function f of x equals x over x plus 1 squared. Okay, and we're going to do this by going through the procedures that we've outlined. Now, you may not need all of the procedures to get an idea of the graph, but in this course, we're going to do all of the procedures and then use all of that information. Some of it will be supporting information. Some of it will give us the same information. Ultimately, if you get two pieces of information that contradict each other, then something's wrong with your math somewhere in there. So looking at this, we're going to start off by thinking about the domain. So thinking about the domain of this function, you notice that we have x over x plus 1 squared. You know that division by 0 is not allowed to happen. It's going to be undefined. So it's going f of x is undefined when x plus 1 squared equals 0. So square root both sides, and you get x plus 1 equals 0, and we get x equals negative 1. So it's undefined when x equals negative 1. So in terms of the domain, we can't have x equals negative 1. The real formal way of saying that is to say the set of all x such that x cannot equal negative 1, and x, however, is a member of the real number system. That's the real formal way of talking about this. I'm not going to demand it, but certainly as you move on, you're going to see this in books and things. So that means the set of all. This talks about what variable it is, variable. This vertical line means such that, and that means that there's rules coming up. Here's your first rule, x cannot equal negative 1. And then this tells you where the variables can come from. So what number set? So are we talking complex number set? Are we talking whole number set? And in this case is an element. X is an element, which is why that's a weird looking E. It's actually, when you draw them, they look like that. An element of the real numbers. Okay, and that's the very formal way of writing it. And again, I'm not going to insist on it, but when someone asks you for the domain here, most likely you're just going to say x cannot equal negative 1. You might be a little bit more advanced than that. You might then say also x is a member of the real number, which is a nice idea. And there you go for domain. Okay, so what's next? Intercepts. Okay, well, for intercepts, we know that for an x-intercept, you're going to set y equals 0. Well, in this case, we don't have a y, we have an f of x, so that's the same as saying f of x equals 0. So 0 equals x over x plus 1 squared. Now, looking at that, we notice that for this to equal 0, it's the top that I'm interested in. So we could jump right ahead and say, so x equals 0, in which case I'll get 0 on top. I'll get 0 plus 1 is 1 squared, so 0 over 1 is 0. The other thing that I showed some of you is just think about that as 0 over top of 1. It could be 0 over top of any number, but 1's the easiest. cross multiply and you end up with x equals 0. And that's another way to do this. So your x-intercept is going to be 0, 0, which is actually the origin. There's only one x-intercept, and it's 0, 0. For the y-intercept, we're going to set x equal to 0. And in our case, that would look like f of 0. So f of 0 is going to equal 0 over 0 plus 1 squared, which is going to be 0 over 1 squared, which again is 0. So our y-intercept is in fact the same as our x-intercept. It doubles as both, and it's going to be 0, 0. So there is our intercepts. Does that make sense? I'm not sure. All right. So let's put that aside, and we're going to need that later. We're going to do a whole bunch of stuff. Now we're looking at symmetry. So we're actually not looking at all types of symmetry. We're looking at only odd or even symmetry. That's all that we're really interested in. If we find out that it's odd, then it's going to be reflected about the origin, which means that it would, well, hold on, let's just jump in. The test for odd or even symmetry is actually, the algebraic test is to put in negative x everywhere there are x's. And if this equals negative x, then what we have is, let me think for a minute, boom, boom, then you have an odd function. And if this equals we'll just keep that like that. So if negative x gives us the same as putting in a positive x, then that will give us an even function. Odd function. So let's do our test. F of x is equal to x over, let's see, what was it? X plus 1 squared. So when I plug in my negative x, I'm going to get negative x in for x on the top. I'm going to get negative x in for x on the bottom. Now, if I take a look at that, I can common factor this negative out so I can see it better. That's a little trick that I do. And what I get is that. So my question is this equal to this? Well, no, there's a negative there, and the x is negative. So we know that this is not equal to f of x. Okay, so therefore it's not even. And we also know that it's not equal to negative f of x. It's pretty close, but look, I've got a 1 minus x down here, and I've got a 1 plus x. So this is f of x. This is what I get when I put in negative x, and it's not negative f of x, because this part is certainly not f of x. Okay? So it's also not odd. So we say that f of x is neither odd nor even. So symmetry is not going to help us in this case. So there's symmetry done. And I think I'll stop here just in case I make a mistake so that I don't have to redo the whole video, and then I'll come right back.